Hello students, this is Brock Skaggs. I'm going to make a video demonstration here of modeling a couple parts inside of SolidWorks. And so as you usually see the parts before you here, we got a default and a configuration A version. Just taking note of the material, it's 7075 T6, so an aluminum alloy, and it's IPS unit system, so everything will be with units of inch for the length dimensions there. And so you can see the two different variations of the part. Going to sheet number 2 here, we've got the default version. So nothing too terribly extravagant. Probably the one thing that's a little bit different is note that we have a tapped hole, but instead of being on a planar surface, it's on a cylindrical face. And so that'll be a little bit different when we get into the hole wizard. You'll actually be kind of operating in a 3D sketching environment there in order to get the correct placement of those holes. But everything else should be fairly standard. You can see a couple of different types of views here. I've got the usual front, top, and right. I've got a detail here showing the cut geometry here and that offsets. And then also in the top view, notice I have this broken out section here. That way I could clearly dimension the depth of the 2.25 diameter cuts on both sides there. That kept me from having to dimension two hidden lines, which is obviously something that you'd want to avoid. And so here's the default geometry. And then if we go to the next sheet, you have all the changes needed for the config A geometry there. And so adding some material near the top here, you got these kind of arms that extend off. We've also got a rib there to possibly stiffen that up. And then we've also removed material in the middle there. And so this will be our goal for this video. And so let's just go ahead and get started then. So I've already got SolidWorks open. I'll get going on a new part. Check the unit system. We are in IPS there in the bottom right, so we're good to go there. And then the material, it was 7075 T6. And so let's go ahead and add that in as well. So right under the aluminum alloys, scrolling down toward the bottom. And here's our 7075 T6 there. And we're good to go. Now just taking a note to note the orientation as well as the origin placement. The origin placement is on that very front face. You can see that, I believe, right here. If I zoom in, that little sketch kind of asterisk looking or star there is the origin. And you can see right here it's at the very center of these circular arcs here, or the whole axis, if you will. And so the way I'm going to start this off is I'll get on the front view bit first, and I will go ahead and sketch the outer profile. I'll probably put in the bigger hole and the smaller hole here, extrude it in the full depth of 3 inches. We can go create the cut in the middle here, and then we can start working on some of the other items there. And so with that being said, I'll go ahead and create a sketch on the front plane. And so the geometry, just kind of picking it as I go. I'll start at the big circle in the middle. It has a diameter of 2.5. And then we've got a straight line coming off the bottom of it at a dimension of 4 from the front view. Then here we've got a nice circular arc here with a radius of 0.5. The way I'll do that is I'll first just draw a circle. I'll know that that circle and this point have to be coincident, and this center of the circle and that point also have to be vertically aligned together. And then I'm going to go ahead and use my 3-point arc tool in order to put this arc here. One thing you'll notice is that these 2 points have to be tangent, so we'll hold control down so we can get the quick access way to add a geometric relation there. And so I'm just holding control, getting both elements selected, and then selecting the appropriate geometric relation. At this point I don't need those inner portions, so I can just use the trim tool to remove those. A radius is 0.5 here, and a radius of 4.5 here. And so that very easily fully defines this portion of the sketch. We've got a diameter 0.5 hole on the left. So just making the hole concentric with the arc, producing the diameter, dimension, and then a through hole of diameter 2 all the way through the part here. Just like so. So that's looking good, and I'll go ahead and extrude it to 3 inches there. So I'll exit the sketch, go right into extrude boss and base, flip the direction so we can maintain the correct origin location. And we're at 3 inches of the overall depth. You can see that right here in the preview there. So going back to the ISO. At this point, it'd be a good idea to check to make sure our ISO looks like it's going in the right spot. Looks like it is. And so let's go back through and put this cut here. And so what I'll do is I'll just get on a sketch on this very front face. Go back to the drawing. 0.25 typical. I'm trying to say, hey, it's the 1/4 inch offset typical here, so it's 1/4 inch from here. This is actually a 1/4 inch from the circular hole, 1/4 inch here. And this one I went ahead and put the radius value for that arc, 1.25, where the center of that arc is actually at the origin there. And so to do that very quickly, we can use the offset entities tool. That defaults to 1/10 of an inch. We want 1/4 of an inch, so making the adjustment there. And it's going to the correct direction, so I'll just put in a series of offsets here in order to achieve 3 of them. Notice this one I've got a flip, so I'll hit reverse. And then we also have a arc in here. And so one thing I can do is I can go ahead and select the full circle, and by default the full circle is going to go to a diameter dimension. But if I left click on the liters, or the dimension value, I can go to the liters tab, and I can actually change it right here to a radius dimension. And so that's exactly what I'm going to do. Check it is 1.25 exactly, which is the value I want. Now I just have some trimming to do. And so I'll use the trim tool here. I can drag across, trim here, 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 and then clean up on the left hand side as well to trim off all of those excess pieces of arcs and lines. So next, the 0.2 round or fillet radius, which is typical, so all 4 of those corners are going to be rounded off with a radius of 0.20. So I'll just use the sketch fillet for that. Go ahead and select the points themselves. And I have the nice fully defined sketch, so it's ready to go for our cut extrude now. And so I'll just exit the sketch. It's still selected, so I'll go straight into cut extrude. And here, instead of a blind, I'm going to go through wall here. That way, in case I ever change the width of this from 3 inches, that through wall cut will always go through wall, and I won't ever have to update that. So what next? Let's make these small 0.5 depth cuts here. And so I'm just going to use the mirror tool eventually to replicate it. But we'll make the seed feature first, the closest one here. And so that's a diameter of 2.25 from the front view and a depth of 0.5. And so I'll just get on the front face here, make my sketch. Go normal 2 as usual. Start my circle. It's centered at the origin. A diameter of 2.25. And then we can extrude cut this circle to a depth of 0.5 to create that geometry. So extrude cut, here's a blind depth 0.5, creates the first part of that geometry. And I could do the same thing if I wanted to. I could come back to this back face, extrude cut another depth of 0.5, but instead I'm going to use the mirror tool. But before I use the mirror tool, I have to have a plane to mirror about. And you can see right now that the front plane is on the very front, the top's not going to be able to work, and the right's not going to be able to work here. And so we're going to have to create a piece of reference geometry. And so reference geometry is right here. We want a plane, and I want a mid-plane really between this face and this face. And so that is indeed one of the options, is midplane. I'm just selecting 2 parallel planar faces, and it's putting a plane right in the middle of them, which is exactly what I'm looking for at this point. And so now I've got this plane 1 in here, which is the one I just created. And now I can go into mirror, the features. I'll go the mirror facial planes, the plane 1 I created. For the features to mirror, I'll go from the flyout tree here, and I believe it's cut extrude 2. And you can see the preview, and then accepting that gets me the result that I'm looking for. So that's looking quite good. At this point, I'll go ahead and hide this plane 1 just so it's not in our way. And at this point, just taking a second to review, I think the only thing we have left are the number 1024 holes on this face. And so, since it is a tapped hole to number 1024 UNC, you'll have to use the hole wizard. And so here's the hole wizard. And first thing I usually do is go over to position. And here I'm going to select this cylindrical face. And so I'll just click a couple points on it and hit escape. And so there's my points, but now I've got to locate them correctly. Alright, now you can see the sketch is underdefined. And so what I'm going to do is I'm going to go ahead and create a line. And so here I'm in a 3D sketch, that's why you see the little pencil and the XY. And so this means I would be sketching parallel to the XY plane. Here I need to draw a line in the Z direction, so I need to make sure that I have something other than XY. So here's YZ. I just manipulated that by hitting the tab key, oscillates between these. And then what I'm going to do is just come over here and I'm going to draw a line. See how it snaps there? Specifically to the Z is what that's saying. And then I'm also going to add a geometric relation here that says that endpoint and the origin have to be along the X direction. Here using the coordinate system in the bottom left of the graphics area. That fully defines this line. I'll go ahead and make it construction. And now what I can do is use this line to fully define the location of these holes. And so both of these holes need to be hole centers, I should say, should be coincident with this line. And then if we go back to the drawing, from the right view you can see they're a 1/4 inch from the outer edges. And so I will just use the Smart Dimension tool to apply those dimensions. And so just like so, I've got a nice fully defined sketch that locates the centers of the circles. Now under type, we'll see I do want a straight tapped ANSI inch bottom tapped holes. The size is 1024 is good, and the condition is up to next for both the hole depth and the thread depth there, which is exactly what I'm looking for. And so it'll go all the way through this wall thickness here. And so accepting that places the holes on the part. Oops. And there's the ISO. And so now we can take a quick check to see if our ISO appears similar to or after here in the drawing. And it looks very close there. I've got some mass properties, so I'll check those. 1.12 pounds for the mass, and then the center mass is at negative 1.59, negative 0.39, and negative 1.5. And so it looks like we are in good shape for the default geometry. And so the next thing I'll do is I'll go ahead and create a configuration for our config A. And so now I've got the config A going here. It's the active configuration, as you can see right here. And let's take a look at the drawing. And so here's our drawing. A few changes here. One is this cut. Then we've got this part coming out here and a rib feature, and then we also have some chamfers to put in here as well. And so I'm going to start working on this cut first. And so what I can do is actually use that plane 1 that I created as a mirror plane as my sketch plane, and then I can do a mid-plane cut extrude in order to get this 1.5 depth of it. And so let's go ahead and get back into SolidWorks. There's plane 1. Just left click on it from the tree and go to create a new sketch on that plane. Just like so. If you look at the sketch or the actual cut geometry here, it's basically going to follow this cylindrical face that we first created. If you go on the front view, you can see where those hidden lines are at for that boundary. And so what I'll do is come in here and I'll create a circle, and I'll make it co-radial with a geometric relation here with the very outside arc. And then I just need to use convert entities to map off the left-hand sections here. And so convert entities, and I'll walk my way around this boundary of the part. And then I just need to come back and trim off this portion here. And so I'll trim off the right-hand portion of that full circle that I started to draw. Now I've got a nice boundary there to use with the cut extrude. It is not blind, but it needs to be mid-plane. And the total cut depth is 1.5, where it splits at 0.75 in each direction there. And so there's that portion. Next, I got this kind of arm that extends off to the top, and so I'll go ahead and create that with a boss extrude. And so I'll just create a sketch on this very front face and start drawing that in. And so I'll just start at the top here. I will place, say, this 0.5 diameter circle. So here's the 0.5 diameter. This location of the circle looks like it's 4 inches above the very base of the part. So here's the 4 inches. And it's 2.5 inches to the right of the center of that hole here. So that fully defines that circle. Here we've also got a arc that's centered about the same point, so that's where we'll do here. I don't have geometric relations showing, so let's go ahead and show. Oh, they are showing. I just haven't applied any yet. And that's a radius of 0.5. So again, here when I first apply it, I'll put a diameter of 1, and then I'm going to come back here and change the dimension by just selecting the dimension, go to the Leaders tab, and change it to the radius value. We've got a nice arc here. So I'll go 3-point arc tool. And right now I'm just first focusing on these coincident, make sure it gets tied together, and then I'll come back in and apply the tangents. Then the radius is 1.5. So as usual, just kind of picking my way through the sketch, making sure that I can get everything as fully defined as possible. On the left hand side we've got a straight line going into an arc, all tangent connections there. And so here's my straight line. Go ahead and use the 3-point arc tool as well. Again, just focusing on things getting tied together first, and then I can go back through and apply the tangents with the geometric relations. And what was the radius? Looks like an R1 value down here. To make sure I get the sketch closed, I'm going to have to use convert entities for the bottom portion. And so I'll use convert entities to grab these portions here. So going to convert entities, selecting those edges, just like so. And then I've got some trimming to do because I don't need this portion of the edge or that portion here. And so I'll go trim entities, trim this portion, trim that portion. Also, I don't need this under portion of that 0.5 radius circle. And so I'll trim that out as well. So that's looking good. Now I can go ahead and exit the sketch. I'll go just ahead and boss extrude it, flip the direction. It's supposed to be the same width as that. I think that is 0.75. Yes. And there's the first part. The parts as far as the arms and the ribs are identical. So what I'll do is go ahead and apply it on one side, and then I'll mirror everything off to the second side. So let's work on creating the rib first before we mirror. And so there's actually a rib tool right here in SolidWorks, so we'll go ahead and use that. What I notice about the rib is it is on the mid-plane of this small planar area here. And so to do that, I need a plane right in the middle of these faces. And so what I can do here is go to plane and go to mid-plane again. Except for now, instead of picking the overall faces of the part, I can pick just those faces and create the plane. So this is plane 2 here. Now what I'll do is get sketching on the plane. So I'll create a new sketch. And with the rib tool, it's really nice because all I need to do to define this rib is a single line. So I'm just drawing my inclined line here. Things I know about the line is that it terminates 1.75 inches above the origin. So just clicking that point in the origin, making sure it's a vertical dimension here and going 1.75. And then here it's at the same spot as the hole as far as vertically. And so I'll just go ahead and put the 2.5 inch dimension in again here. So I'll go smart dimension. There's my 2.5 dimension. And that fully defines the line itself there. Now, in order to use rib tool, this is all I need. I don't need a closed sketch, which is a little bit different from most of the features that you use when you first start learning SolidWorks. And so you just go exit sketch here, Then you go to the rib tool, which is right up here. You can see the arrow saying we're going to pull this in the downward direction to intersect the material, which is good. I believe the rib thickness is 0.250. And right now we're also on the mid plane, if you will. We're going to go both sides here. So one side goes 1/8 of an inch, the other side goes 1/8 of an inch. And just hitting accept there very quickly creates that rib feature. Notice it goes right until it contacts the contours of the existing geometry, which is a very convenient thing for us. Also, you'll know this rib is not flat on top. You can kind of see from the hidden lines here, it's got a nice circular arc. That's a full round fillet, actually. And I'll go ahead and hide plane 2 from view. And the full round fillet, you just go to fillets. Instead of this one, which is the usual one, the nice constant size fillet, you go to the far right here in 2015 is the full round fillet. You got these 3 boxes. You can kind of see how the faces of this cube are highlighted in different areas. And so you basically pick one side, you pick the middle side, and then you pick the other side. And as you can see from the preview, it's going to create that nice full round fillet all the way around. And so there's that much. And let's go ahead and just mirror this over. And so we're mirroring about the midplane of the part, so that's plane 1. So I'll have that pre-selected here, and I'll go right into mirror. That obviously populates the mirror face and plane. And the features I want to mirror the boss extrude 2. I want to mirror the rib, and I also need to mirror the full round fillet there as well. And then hitting accept gets the geometry on the other side of the part. I think the only thing we have left now is the chamfers. Here this note saying, hey, there's 8 chamfers. All of them have a distance of 0.1 and an angle of 45 degrees. And so I'll go to the fillet, but I'm not going to hit fillet. I'm going to hit the drop down to go to chamfer. 0.1 and 45 degrees is the default there. And then select edges or faces. Here I'm just going to select the cylindrical faces because I need the chamfer to go on both ends there. And so just with those 4 selections, I can generate the 8 chamfers. So that looks good, so I will accept it. And I believe now we are at the configuration A geometry. So if you go to the cover sheet here and compare, looks quite similar. And then we'll just go to the mass properties under evaluate in order to check there. And so 1.34 pounds for the mass, center mass at negative 1.31, 0.45, and negative 1.5. And so that looks good. Those are the values that I was looking for. And so that should wrap up this video. And so, as always, thank you for watching.